famous idea that any sufficiently advanced technology appears magical still provokes deep reflections about our place in the universe. In light of this, an uncomfortable question arises. Should we be content with observing the cosmos from a distance, living comfortably on Earth without daring to go further? For many thinkers and scientists, the answer has always been clear. The human drive to explore, create, and advance has never allowed complacency. To understand what lies ahead of us, we need to look back and see how past decisions shaped the future that is beginning to take form now. In a not-so-distant scenario, humanity takes a historic leap when SpaceX sends the first starship toward Mars, opening the path for a human presence on the red planet. Meanwhile, on Earth, digital fabrics become part of everyday life. These smart garments incorporate sensors and small displays capable of collecting data from the human body, analyzing patterns such as muscle effort, sleep quality, and exposure to sunlight. Some companies go further and combine these fabrics with virtual reality, allowing players to feel vibrations, heat, and cold during immersive experiences. At the same time, NASA begins the Artemis missions with the goal of establishing a permanent presence on the Moon. This return is not merely symbolic. New intelligent construction materials start to emerge on Earth, including bricks that function as batteries, capable of storing energy and even digital data. The most anticipated moment arrives when the first humans finally leave Earth bound for Mars, traveling aboard a starship. During the roughly 7 months of the journey, astronauts use virtual reality glasses as psychological support, helping them maintain calm and emotional balance in the confinement of deep space. During this period, human interaction with digital artificial life forms intensifies. These virtual beings learn on their own, develop their own behaviors, and begin to coexist with humans in digital environments, creating a new kind of virtual ecosystem. As technology advances, wearable devices give way to subcutaneous implants. Small chips begin to be inserted under the skin, connecting people to their smart homes and robotic devices, all controlled by voice commands. In the medical field, neural implants begin to transform lives. Advanced chips manage to restore sight to blind individuals and return movement to people who were previously paralyzed, redefining the limits of medicine. Global communication also changes radically. A universal translator starts to be used in international institutions such as the UN, drastically reducing the need for human interpreters. In the chemical industry, quantum computers enter the scene, accelerating the development of new medicines, biodegradable plastics, and innovative construction materials. 5G networks, carrying massive volumes of data, take control of traffic systems and autonomous vehicles, making cities more efficient and organized. Beyond Earth, the interplanetary internet is born. A space communication network connects landing robots, satellites orbiting planets, and ground stations. A rover on Jupiter, for example, sends information to a local satellite, which relays the data to Mars, and from there to Earth. On Mars, automated factories begin operating, producing 3D printed habitats, as well as water, oxygen, and laboratory-grown food, all prepared for the arrival of more explorers and scientists. Meanwhile, in Earth orbit, a luxury hotel receives its first guests. In parallel, a new commercial space station begins operating exclusively for scientific research. On Earth, bioplastics gain ground, manufactured from renewable sources such as sugar and fungi. Reprogrammable microchips allow physical equipment to be updated in the same way as software. Entertainment also breaks boundaries when production begins on the first major Hollywood film recorded entirely off Earth, using sets in orbit and on the lunar surface. The Starlink satellite constellation reaches full operation, offering global internet. One of the most impactful advances occurs when the first industrial-scale nuclear fusion reactor comes online, generating clean energy by fusing hydrogen atoms. Biotechnology advances rapidly. Anti-aging medications begin to eliminate cells associated with the aging process. Neural implants are no longer restricted to medical treatments and start being used by healthy people seeking enhanced abilities. Even the judicial system is impacted, with the creation of the first judge based on artificial intelligence responsible for sentencing crimes. As remote work evolves, many people begin operating in fully virtual environments. Smart fabrics evolve into physical assistant suits, helping the elderly walk, regain mobility, and even acquire extra strength. These suits also guide users in learning new motor skills. Smart tattoos, with integrated circuits, allow control of devices around the human body. 4D printing emerges as a revolution, creating materials capable of changing their shape and function according to the environment, reacting to light or heat. Artificial organs produced through 3D bioprinting become common. Swarm robotics becomes part of daily life, with small robots that communicate with each other, cooperate on complex tasks, and even physically organize themselves to form structures such as temporary bridges. Cognitive amplification brain implants become popular, assisting memory, reasoning, and problem-solving. Advanced verification systems emerge to differentiate humans from machines. On the Moon, permanent settlements begin operating, functioning as research centers and connection points between Earth, Mars, and more distant regions of the solar system. A space station in lunar orbit begins operating, further expanding human presence in space. Global events also transform. Millions of people watch the Bionic Olympics, where athletes with robotic prosthetics compete on equal footing. Self-cleaning clothes enter the market, using micrometals that break down dirt when exposed to sunlight. Interstellar exploration takes a bold step with the launch of the Starshot Alpha Centauri project. Thousands of microprobes equipped with solar sails are propelled by lasers, reaching significant fractions of the speed of light. The goal is to fly by Proxima Centauri b, an exoplanet located in the habitable zone of its star, and send data back to Earth. In astronomy, the Square Kilometre Array comes into operation, with antennas spread across deserts in South Africa and Australia. This system becomes dozens of times more sensitive than the Hubble telescope, capable of detecting signals from possible extraterrestrial civilizations. On the Moon, habitats printed in 4D begin to be built, absorbing solar energy and micrometeorite impacts, converting everything into electricity. The construction of spacecraft directly on the Moon becomes common practice, facilitating exploration of the solar system. Genetic engineering creates plants capable of surviving the hostile environment of Mars. Neural implants allow direct communication between brains, eliminating the need for speech. Every moment of human life begins to be recorded, from childhood to old age, including internal thoughts, which also opens space for digital crimes, such as the implantation of false memories. Nanosensors circulate through the bloodstream, monitoring health in real time. Police forces begin to rely on robotic units on patrol. At a certain point, the number of robots surpasses that of humans. Extinct species return to life, including woolly mammoths recreated from preserved DNA, living in controlled reserves. Asteroid capture operations begin, with robots guided by artificial intelligence diverting celestial bodies into orbits near the Moon and Mars. These resources are transformed into raw material for new space constructions. Stem cell therapies regenerate lost limbs, teeth, and tissues. Genetic engineering adapts the human body for long-term stays in space, reducing bone and muscle loss. Hundreds of thousands of people begin living on Mars. On Earth, children inherit the digital records of their parents. Compact and efficient reactors provide portable energy for civilian, military, and exploratory use. The human experience expands even further when dreams begin to be shared and transmitted, allowing people to dream together in virtual environments. General artificial intelligence emerges from quantum supercomputers, achieving self-awareness. Communication between species becomes possible. Robots conduct funerals for other robots. Artificial life forms begin to be born, designed by quantum computers capable of creating organisms from scratch, from bacteria that consume plastic to custom-made human beings. Human life expectancy extends for millennia. Artificial intelligences gain corporate status. A global system manages ultra-high-speed transport networks, making commercial flights obsolete. Self-regenerating materials become standard. Molecular assemblers allow food to be created instantly. Humanity spreads throughout the solar system. Robotic fleets transport resources between planets. Experiments with space warp begin to work, distorting space-time. Mars declares independence. Humanity reaches the level of a Type 1 civilization, controlling the climate, the oceans, and geological processes. Giant structures begin capturing the energy of the sun. Generation ships depart toward other stars. Earth enters a new glacial period, reversed through environmental engineering. Humanity reaches the status of a Type 2 civilization, mastering the energy of entire stellar systems. Human consciousness is transferred to quantum supercomputers, allowing travel and existence within simulations. Robots prepare new stellar systems before human arrival. Consciousnesses are transmitted as data, taking on new bodies adapted to each planet. At this stage, humanity moves toward becoming a galactic civilization, manipulating space-time itself and encountering other forms of existence beyond matter. In the end, control over its own evolution ceases to be a dream and becomes reality.